Good morning, guys. I apologize I can't be with you today, but this is what I want you guys to do for Monday, October the 14th. We are going to remediate on 1.1 and 1.2, and that is analyze and determine the characteristics of a graph or functions and apply it to real-life scenarios. So this is a remediation because I handed back your paper. Please put that away. Leave about 3 pages for 1.3. When I come back either tomorrow or Wednesday, I will go over 1.3 again. All right, so let's go ahead and get started. Add this to your notebook. Go ahead and add it to your table of content. Today is October the 14th. And go ahead and put 1.1, 1.2 remediation, okay? And find a page for it. I have printed your notes, so I want you guys to kind of follow me as I complete the notes. All right, so here we have different types of notations. Here's a graph. Here's the type of interval. Finite means it has an end and a beginning. Infinite means one side of it goes on forever. Notice how this is open and this one is closed. Open means it is not part of your solution. Notice how there's no equal sign. Closed means it's part of your solution, so A is part of my answer. Notice there's an equal sign. This is an inequality notation. This is a set notation. Notice how it writes. And remember how this says x such that x is greater than or equal to a. And here's an interval notation. This is the one I prefer, but I want you to make sure you recognize all the different kinds. Okay? For end behavior, I like you guys to write it in limit notations unless it's specified. So you will see how I have it written a certain way, and then I'll say, hey, I want this in limit notations. So just kind of be aware of the different ways to write it. All right, let's take a look at this first one. This first one, I want you guys to write it in inequality notations. So that means we're going to write it like that, okay? So let's take a look. We have a graph here. Our graph starts here and it heads in this direction, okay? Your domain is always from left to right. So how far to the left is this graph going? It's going on forever. So in other words, this x is going to go from infinite. So it's going to go from negative infinity to positive infinity. So x is always going to be no matter what. So how would I write that? Well, you can write it where x is greater than infinity, okay? And x is also between positive infinity. So honestly, you can write it negative infinity, less than or equal to x. You could write it like that. There's your x value for your domain. That is not how I prefer. That is not how you usually see it, but that's okay. Your range is always your y value. Notice I start down here and it goes all the way up. So negative infinity is greater than y is greater than infinity. And there's your inequality notation. Where do you cross the x-axis? It's crossing right here. Now, I don't have an equation, so I'm going to estimate. That could be 0.5, 0.4, but write it as a point. So that would be 0.5, comma, 0. Always write it as a point. Your y-intercept, you're crossing right here. Where do I cross the y-axis? That looks like 0, comma, 1. And since I don't have an exact equation, I'm just going to estimate, okay? Interval increasing. Where is it on this graph that is increasing? Well, it's increasing never. It does not exist. Look from the left. See how your graph is never going up? It is always going down. And you can write does not exist, or you can write not applicable. Either way. Interval decreasing is, hey, I am decreasing from negative infinity, okay? And it's always your x value, always to positive infinity. I actually don't like to write it like that. I would prefer you don't write it like that. Think of it like a number line, okay? All right, now let's take a look at your end behavior. Okay, this is the one that you guys struggle with the most, so I want to put this in blue. This is your left. To write it as an inequality notation, we're going to write it as this, okay? X is approaching from negative infinity. what is happening to y when it is approaching from negative infinity? It is going up. Where is up? To positive. So you can actually write it like that. This is very common how to write it. The right end behavior. Notice I'm heading in the positive direction for my x. As I'm heading in the positive direction, what is happening to the y? The y is heading in the negative direction. So as x is coming from the left, which is negative infinity, right? It's coming from this direction. It is going up. Do you see that? On the right side, as it's heading toward the positive infinity, it is heading down, okay? This is not the preferred method, but I want you to see it just so you know. All right. Next part, we're going to write it as a set notation, okay? So here I have a parabola. It is a quadratic. There's some points I know, so I'm going to go ahead and label some points. Right there is 0, 4. Right here is, that is not 0, 2. It is 2, 0. So let me write that correctly. And right here it is negative 2, 0. All right. So those are some points I can tell. I don't have an equation, so I'm just going to look at it and I can kind of tell those points, okay? So let's look at our domain. Your domain goes from left to right. So I'm going to write it as a set notation. So I'm going to have this, I call it the squiggly, but there's a name for it, and it's going to be my x value. Such that x, you notice how it's from negative infinity over here, going all the way to positive, because it doesn't actually stops right here. It continues on forever and forever. So x is going to be between negative infinity and positive infinity, just like that. Your range goes from your low to your high. So y such that, where's my y? My y starts at negative infinity, but there is a stopping point, and it's stopping right up here. That's your maximum. What is that y value where it stops? And it's including that point. So it's going to be a 4, okay? So notice I added an equal sign for the 4. And draw your squiggly. Not the preferred method, but if you see it, at least you will know. Let me rewrite this one a little bit better. Negative infinity. There you go. All right. Your x-intercept. Where are you crossing the x-axis? It is always a point. Negative 2, 0, 2, 0. Sometimes you don't have an x-intercept, okay? Y-intercept. I'm crossing the y-axis at 0, 4. Always a point. Interval increasing. I start here at the left. Where's my graph going? It's going up. Notice I put my hand right there, or my ruler right there. So where is it going? Well, it is going from negative infinity, not the preferred method, okay? But I'm going to write it because I asked for you to write set notation. So x, what is x doing? It is going from negative infinity all the way to 0. X value only. This is always your x. So from this point up to about right here. So starting right here, my graph is going up, stopping right there. Is my x value 0? Is that part of it? No, because at 0 it's constant. There's no slope. Okay? Interval decreasing. Well, starting from 0, not including 0, notice I'm going down. All right? So this one would be x such that from 0, not including 0, heading toward positive infinity. Not the preferred method, but it asks for set notation, so I want you to make sure you write it like that, okay? In behavior, all right, this is not how you usually write it, but we're going to go ahead and write it like this. X is negative infinity. What is happening to your y? As x is coming from negative infinity, it is going down. And where is down? Negative infinity. There's your end behavior. Look at your right side. As I'm heading toward the positive, what is your y doing? It is heading in down direction, which is negative infinity. And there you have different ways of writing it, okay? Now, we're going to go into the part that I like to write. And this is how I want you to do it, unless I specify to write it a certain way, okay? But I want you to recognize all these different ways, so if you are taking a test, or maybe the book does it a little differently, you would understand what it means. Okay? All right. So here is the way I want you to write it. I want you to write it using interval notation, and I also want you to use limit notation. So here we go. Domain. Now look at my graph. Open, heading in the increasing position. Do you guys see it? Okay. This is how I want to write it. Your domain goes from left, comma, right. This is the only part you need to worry about, bracket. What is your x value right here? -1. Is that -1 part of my solution? No. Parentheses. And I'm heading to the right. Where's the right? Does it stop right here? Actually, it goes on forever. So I'm heading to the right, and what is right? Positive infinity. And infinity is always a parentheses. Okay? Take a look at your range. Your range is floor, comma, ceiling. Okay? So look at my floor. What is my y value right here? -3. Always go low to high. That -3 is not part of it, so it's going to be my parentheses. And I'm heading up. Where is up? Up is towards positive infinity. Parentheses. See it? X-intercept. I don't have a function, so I'm just going to look. I'm crossing the x-axis at 2, 0. It is a point, and that's the only point you're seeing it crossing the x-axis. Y-intercept. Right here. Where is it crossing the y-axis? At 0, -2. It is also a point. Okay? All right. Interval increasing and decreasing. Let's take a look at this graph. From where to where is my graph going up? It is always your x value. This is always your x value. You guys got it? Always your x value. So at -1, I'm heading up the whole way to where? To positive infinity. And this will always be parentheses. Okay? Interval decreasing does not apply. This graph is never going down. See how I look from my left? It's never going down. Now look at your end behavior. Okay? You're making a statement. So you're saying my limit coming from the left. As I'm coming from the left, which is right here, there's your left, what is happening to that y? Well, that y is not going down. It's not going anywhere. It is heading toward -3. So you can write do not exist, because there's no limit to this at all. So it does not exist. Okay? Notice, here is your statement, and there's your result. So this is your statement. These should always be together. That x should be right under the word limit. Let's look at the right side. Here's your right side. What is happening to my graph as it's heading in the right direction? Well, it's heading to the right, which is positive infinity. It is what's happening to that y value. It is heading up. Do you notice how the limit and the word and the statement, x, where is it going toward, where is it coming from, is together. Okay, so here's my statement, and that's your result. So think of it like a sentence. Subject, verb. All right. That is how I want you guys to really learn how to write it. Okay? This is my preferred method, unless specified. Please write it like this using interval notation. But I do want you to recognize the other method. All right, let's look at example 4. Here we go. You got a graph. Okay? It's going from here to here. This is an exponential graph, as you can see. This one is approaching this x-axis, but it's never crossing, no matter what you do. All right, so that right here, by the way, this is called an asymptote. We'll talk more about that when we get into more exponential, but right now this is all I need. All right, your domain. Where am I starting from? I'm starting from negative infinity. I'm heading toward the right, never stopping. See that arrow? It continues on. So you can write negative infinity to positive infinity, or you can draw a 2-line and write an R for all real numbers. Either one is going to work. Your range, where am I starting? I'm starting at y value being 0. not included. It's approaching but never touching, heading towards the positive infinity, okay? X-intercept, never cross, not applicable. Y-intercept is crossing the Y at 0, 1. So just, you're analyzing a graph. Interval increasing. Well, from my left, this graph is going up the whole time. So where am I increasing from? Negative infinity to positive infinity, and it is never decreasing. See how your graph is never going down. All right, so here's the end behavior. Here's my statement. I got negative, so I must be talking about the left. So as I'm heading in this direction, I am heading toward 0. Do I ever touch 0? No. But it does continue on forever, so I'm going to write 0. Okay? So, next part. All right. Right end behavior. Well, X is approaching positive. Well, as I'm going toward the positive, what is happening to that Y value? It is heading up. This one has a 0 because it doesn't stop. In example 3, there's a stopping point. See the difference in the two. Okay? See Y1 is D and E, does not exist, and the other one is 0. So make sure you are aware of that. All right, let's keep going. Example 5. Okay, let's take a look at this one. Okay, so here's a turn. I'm not sure what that point is, but we're going to make up, that looks like negative 0.5 and negative 6. Okay, so that way you kind of have a point of what I'm talking about. Domain, far left, it doesn't stop here. Far left to far right. So you see my graph. Okay, you see that? Here we go. So my domain is negative infinity to positive infinity. My range starts at negative 6, including negative 6, so it'll be a bracket going all the way to positive infinity. See that? X-intercept, I have no idea what that point is. Oh, wait. That is not negative 0.5. I lied. Let me look at this. This is actually 2, so that looks like negative 1. Okay, my fault. All right, so this right here, x-intercept, it looks like it's crossing at negative 2, between negative 2 and negative 3. How about negative 2.5, comma 0? I don't have an equation. It's not giving me a point. I'm just estimating. Crossing the y-axis at almost negative 6, so maybe 0, comma negative 5.5. You write negative 5.4, I won't count it wrong, I promise. Okay? Interval increasing. Well, from here to right here, my graph is going up, right? So where am I going up from? And I said that was negative 1, heading in toward the positive direction. Decreasing. Here's the graph. I'm going down. So where am I going down from? Negative infinity to negative 1. Negative 1 is slope is 0. That's why it's not included. Here's your end behavior. Limit notation. Okay? As I'm coming from the negative infinity, I'm heading up. So my y is positive. This one, as I'm going toward positive infinity, my y is also positive. All right, so there you have it. Do you see how the ends, don't care about the middle, just the ends. Okay? This is how I really want you guys to write it. Keep that in mind. Interval notation, limit notation. Okay, let's go to number 6. Here I have a graph. Okay? And so here I'm asking you to write it as a set notation. Let's not do that. Let's go ahead and do interval notation. Get you guys used to that, because you are more familiar with set and inequality, but not interval notation. Okay, so what is this point here? So this is negative 4, negative 3, negative 2, negative 1. All right. So negative 2, comma 0, 2, comma 0. Let me see, 4, 3, 2, so 0, negative 2. I'm writing those points just so I can see. Here's my domain. from -2 to 2. And -2 is part of it, ending at 2. And I'm going to write the set notation a little bit. The range goes from low, -2 to 0. See how it's part of the answer? I'm crossing the x-axis at -2, 0, 2, 0. Your y-intercept is 2, -2. Interval increasing. I'm increasing from here, going this way. So where am I increasing from? X value, 0 to 2. There's my interval. Interval is like month. January to February, February to March, March to April. Interval decreasing. So from here over here, I'm decreasing from -2 to 0. Okay. Let's look at our end behavior coming from -infinity, which is the left. What is happening to that y? Well, there's no arrow there. It's not going anywhere, so it does not exist. Let's look at your right end behavior. Okay. Positive infinity. See that? There's no error either. It's not approaching anything, so it doesn't exist. All right, so if I were to write this as a set notation for my domain, it would look like this, okay? X, such that X is between what? -2, including that, and 2. There's my set notation. So I'm going from -2 to 2, okay? For your range, just so you guys can see, y, such that what? Y is between -2 and 0. So -2, such that y and 0. -2 is less than or equal to y is less than or equal to 0. And they're a part of it. So that's how you would write that as a set notation. Okay? Just so you see. And if you were to write this as an inequality, it would just be that right there. So there you go. All right, I hope this makes more sense. Okay, next part, given a graph. So now we have a graph. Identify the maximum value. Where is your highest point? Right here. And what is that point? 4, 6. Okay? Minimum, lowest point, here's your lowest point. What is that value? 1, -2. Just looking at the graph, that's not low, that is your lowest. Okay? That is called, by the way, later on you learn that this is absolute minimum. And this one is low, but it's not the lowest, so that's called relative minimum. You only has one absolute, but all the others are going to be relative, okay? So just like this one here, this is an absolute maximum, and this one here is a relative maximum. Highest, high. That's all that means. All right, so let's take a look at the very last one. Okay, so this just looks over the interval, -4 and -3.5. So between here and -3.5, what is happening to the graph? It is increasing, so it is a positive interval. And what am I looking at? Domain. So I'm looking at what value? X value. Okay? So how about the interval from -3.5 to 0? Well, what is happening there? From -3.5 to -2, it is increasing. To what? 2, it is positive. And then from -2 to 0, okay, it is negative. All right. How about 0 to 1.75? That'll be about right here, right? So for that one, from 0 to 1, it is positive. Ooh, I lied. It's negative. Sorry. Negative. And then from 1 to 1.75, it is positive. And how about the interval from 1.75 to x to 4? That one is definitely positive. All right, so there you have it. And I hope this helps you guys a lot. Okay? And go ahead, once you get all these notes done, I want you to go to Google Classroom and complete those online. So, have a good day.